Math 3, Unit 11, Section E. So basically today we're going to be using the laws of logarithms in order to get condensed to single logs so that we can solve log equations. Okay, there's basically two ways to solve log equations. One is if you end up with a single log on each side of the equal sign, you can drop the logs. Okay, which is funny, but you can do that. Okay, the other thing is that if you end up with just a single log, and we're going to get to that on one side, we would change it to exponential form in order to eliminate the log. Okay, so we're just going to kind of, you guys can read the directions if you want to go through that, but we're just going to go through examples. Okay, so on this first example, do you see how there's a single log on both sides? Okay, so we are just going to drop the logs, and we end up with x over 7 equals 3. And can we solve that?
Yes.
Yes, we can. How do you eliminate a fraction? How do you get rid of the 7 in the denominator? Very good. And so we do that. These cancel, and we get x equals 21. Okay. So, next example. We're going to go down. Okay. Here, we have natural logs. See how there's a single natural log on both sides? We can eliminate the natural logs. Our equation now is 3x plus 5 equals 7x plus 2. What would we do to solve that?
Subtract 5 or subtract 2.
Good. I like positive numbers, so I'm going to subtract 3x to both sides, and then I'm going to subtract 2 to both sides. So 5 minus 2 makes 3, and 7 minus 3 is 4. So we have 4x. Again, we're just combining like terms. We're getting all of our like terms on each side. And then the last thing we do is divide by 4 to both sides. And so the answer is 3/4. Okay, here, do we have a single log on both sides? No. So what do we need to do? We just did it this last unit, or the last lesson. We need to condense, okay? And so when you're adding, how do you condense? What happens? Changes to multiplication. So I end up with log base 8 of x times x minus 6 equals log base 8 of 7. Is everybody okay with that step? Okay, now I can eliminate the logs. So I couldn't hear when you had multiple logs on one side, but when you have one single log on both sides, that is when you can cancel them out. So now we have x times x minus 6 equals 7. What would I do to solve this? Good. Distribute the x through. We get x squared minus 6x equals 7. Anytime we see an x squared term, we're probably going to have to do what? Factor. And in order to factor, it needs to be set equal to 0. And so I'm going to subtract 7 to both sides. I get x squared minus 6x minus 7 equals 0.
Can you explain how you get the smaller equation? I just don't remember.
From here to here?
Yeah, like how you're eliminating logs and stuff.
So whenever you have adding, and this is what we did on the last lesson, is when you have adding, you can condense them to a single log, and addition changes to multiplication. So this log base 8 goes down, and then you multiply x times x minus 6. If it was subtraction, you would end up changing it to division.
Okay.
Okay? And then once you have a single log on both sides, you can eliminate it. It's like I'm dividing by a log of 8 to both sides, and it cancels out.
Okay.
Okay? All right, so then factoring, which is something I'm hoping that you guys are good at. Remember, your middle number is your adding, your ending number is your multiplication number, and so what multiplies to be negative 7 and adds to be negative 6?
1 and negative.
Good. X minus 7 and x plus 1. When you set those equal to 0, what does x equal?
7.
X equals 7 and negative 1. Now, one thing with logs, and that we even kind of talked about when we were graphing them, is that you can never end up getting a negative number here. Okay? Because if you were to change this to exponential form, it'd be like 8 to the y equals x. You can't ever get a negative number. So when you see a negative answer, it doesn't work. So therefore, the only answer is x equals 7. Okay? Any questions? All right, so we're gonna move on to the next example up here. So what do you think we need to do first on this one? Condense. And in the condensing process, you first need to what? Good, the exponent, the number in front needs to become an exponent. So both of these numbers need to get moved up. And so I have log of x squared equals log 2 to the 6th power minus log 4. What would be my next step in the condensing process?
You would then change that to a, call it division.
Good. Subtraction, we'd condense these 2 logs into a single log, and subtraction changes to division. And so we have log of x squared equals log of 2 to the 6th over, this was supposed to be a 4 here, sorry, over 4. What base does this log have? Good, 10. So anytime it's log base 10, we don't write it. Or you could write it, but it's not necessary. So now we have a single log on both sides. Those eliminate. We get x squared equal, and what is 2 to the 6th power? 64 divided by 4. And what's 64 divided by 4?
4, 8, 7, 16.
Good. 16 is correct. And then we take the square root of both sides, and x equals, it would normally be positive negative 4, but can we have a negative answer? No. So we can't have a negative, oh, actually, well, we're just going to say x equals 4. Okay. Next one. What happens on the next one? Do I need to do any work at the beginning?
Well, you've got to drop it.
Yeah, we just have to drop the logs, okay? And so we end up with 2 to the 3x equals 32. Do you guys remember how to solve this type of equation?
No.
Okay, you have to end up getting like bases. So this has a base of 2. Is there any way of changing 32 so it's 2 to some power?
Yeah, just leave it.
Good, 2 to the 5th. So we have 2 to the 3x equals, and 32, we can write, oh my gosh, we can write 32 as 2 to the 5th power. Do we agree with that? That 2 to the 5th is the same as 32, so we're just changing the form. Now, we can actually drop those bases, and we end up with 3x equals 5, and what will we do to solve that? Divide by 3 to both sides, and we get x equals 5/3. Okay, any questions? All right, the next one, we need to do what first? Condense. Are there any exponents to bring up? Nope. So subtraction, we're going to change that to what? Division. So we have log base 2 of 5x minus 4 over x equals log base 2 of 3. Once you've condensed and you have a single log on both sides, we can eliminate our logs. We have 5x minus 4 over x equals 3. What should I do to eliminate that x?
Get rid of the x top.
So we can multiply by x to both sides like that, right? And so the x's in the denominator, that x eliminates. So I have 5x minus 4 equals 3x. And in order to solve, what will I do next? Subtract 5x, good. So now I have negative 4 equals negative 2x. And my last step would be to do what? Divide by negative 2 to both sides. And so x equals 2. Any questions? Yes, Jordan.
Yeah, so, okay, so you got the logs of those applications now. How did you get the x? The x to the left?
This one?
No, the one to the one, oh, I guess to your right.
This one right here? This one right here?
No, the other one, yeah, that one. How did
Okay.
you get that one in order to confront the x?
So I had this equation right here. 5x minus 4 over x equals 3. Anytime you want to eliminate a fraction, you multiply by the denominator. And so since the denominator is x, I chose to multiply both sides by x in order to eliminate the fractions. Okay? So those canceled, and that's how we have 5x minus 4, and then 3 times x is 3x. And then I solve from there. Okay? Any other questions? All right. We're going to go ahead and keep going. So on this one, if you notice, a lot of the problems end up just having you can condense it to a single log, but you don't have a log on both sides. Once you condense it to a single log, you can eliminate the logs by changing them into exponential form. Okay? So the first thing you always want to do is if you have multiple logs on one side, you need to condense them to a single log. So if we start here with this example, in order to condense this, I would write this as what?
Log base 4
Good.
to 28 over x.
28 over x equals 2. Is everyone okay with that first step, with condensing? So as a subtraction sign, when I condensed it, it changed it to division. Now you'll notice here that there is not a log on both sides. Okay? So we have to change this to exponential form. And this we kind of did a couple weeks back, and then we took a break. So in order to change this to exponential form, does anybody remember what we do? So you always take this base, which is 4, and it gets raised to whatever's over here as its exponent. So this is 4 to the second power equals, and then this right here is the answer that goes on the other side, 28 over x. So again, the base of the log becomes the base of the exponent, the base here, and then this number is your exponent, okay? And then this is the answer on the other side of the equal sign, always. And we did this a lot back, but it was like 2 weeks ago. 4 squared is what?
16.
So we have 16 equals 28 over x. I do not like that x in the denominator. Jordan, what will I do?
You multiply x to both sides.
Very good. So we multiply x to both sides. By doing that, it eliminates the x that was in the denominator. And so now I have 16x equals 28. What will I do to x by itself? Divide by 16, and then you would want to reduce. And I know I can divide by 4, and I get 7 over 4 once that is reduced. Do we have any questions there? Okay, next example. Again, we want to condense this to a single log. Okay, so since it's adding, when I condense that, what will it be?
Log. And then you go x times 4.
Good, x times 4, and I'm actually going to, we normally put the numbers first, so I'm going to write that as 4x, because when I'm multiplying x times 4, we would really write that as 4x equals 3. Okay, I can't drop this log because there isn't a log on both sides, like it was in my previous examples. So we change it to exponential form. But what is my base on this one? 10. So you might want to write a 10 there to help you out. And so when I change this one to exponential form, how will I write it?
10 to the 3 equals 4x.
Perfect. 10 to the third equals 4x is correct. And so what is 10 to the third power?
1,000.
1,000. So we have 1,000 equals 4x. And then my last step would be to do what? Good. Divide by 4 is correct. So x equals 250. Any questions? Okay. Next example, it already is a single log, specifically a natural log. I talked about this in our previous lesson, but what is the base for natural log? E. Okay, the only base natural log can have is E. This one can't change. Okay, where logs can change, natural log cannot change. And so when I rewrite this in exponential form, how would I write this?
You would have
E to the
negative
2
2
equals X. When we have E in our answer, we're not going to plug it into our calculator. We're just going to leave it in terms of E. But I don't want a negative exponent. So how would I eliminate the negative exponent? Yeah, change it into a fraction, and anytime you have a negative exponent, it goes to the opposite side. And so we end up with E squared in the denominator, and if nothing is in the numerator, we just put a 1 there, equals X. And that's it. That's your answer. Any questions? Okay. Next one. What's the first thing I'm going to have to do? Condense. Adding is going to condense and make it into multiplication. So we have log base 3 of 3 times x minus 5. And again, because it's multiplying, your order doesn't matter. And so I always like the number in front before the parenthesis. Okay? Equals 4. So now I have a single log, but I don't have a single log on both sides. And so therefore, in order to eliminate the logs, we need to do what? Exponential form. Very good. So this is going to be what? 3 to the 4th equals, good, 3 times x minus 5. And then we're going to simplify. 3 to the 4th power is what? 81. Because 3 times 3 is 9, and then 9 and 9 is 81. Okay, and then we distribute. And we get 3x minus 15. Then we will add 15 to both sides. We have 96 equals 3x. And the last step is to divide by 3, which gives us x equal to what? 32 is correct. Any questions? Okay. Normally I'd have you do the next one on your own, but for time's sake, we're going to just keep plugging away here. What would be my first step on this next problem?
You would get base 5.
Before that. Good. Any number in front needs to become an exponent. So I'm going to rewrite this as the natural log of 2 to the 3rd power plus the natural log of x equals 5. Okay, then our next step is to do what, Dana?
Oh, and then you're going to combine them.
Very good. We're going to condense, and adding changes to multiplication. So we have the natural log. I'm going to go ahead and just multiply this out. 2 to the 3rd power is what? 8. 2 to the 3rd is 8. And so I'm going to have the natural log of 8x equals 5. Okay? What base is natural log always? E. Okay? And so in order to eliminate the natural log here, we change this to exponential form, which we've written as what? E to the 5th equals 8x. Is x by itself? No. So what's the last thing we would do? Very good. Divide by 8 is correct. And so that's your answer. We leave it in terms of E. X equals E to the 5th over 8. Any questions? Okay. We have 2 problems left. We're going to go ahead and finish. Oh, yes. Question.
Are the natural logs and the regular logs the same thing? Like the ln and the...
Yes. It's just that natural log is base E. Yeah. Okay. Here we go. Last 2. Okay, so again, if you have pi or e in your answers, you just leave pi or e in your answers. This one, the first thing we're going to do is...
Get the stuff in the back.
Very good. Move that to your exponent. So we have log of base pi of 5 to the 2nd plus log base pi of x equals 3. We condense. Because it's adding, when we condense, it becomes what? Multiplication. We know that 5 squared is actually what? 25. So this will become 25x equals 3. 3. Next, we'll change this to what? Exponential form. Thank you, Mr. Snyder. So we have pi to the third power equals 25x. Last step to get x by itself would be to do what? Divide by 25. So these cancel. So x equals pi to the third over 25. Do we have questions? Okay. Last one. Subtraction will change to what? Division. So we're going to condense. We have log base 7 of 3x over x minus 2 equals 0. Changing it to exponential form, how will I write that? 7 to the 0 equals 3x over x minus 2. What is anything to the 0 power? 1. So 1 equals 3x over x minus 2. Jordan, how will I eliminate x minus 2 from the denominator?
Multiply x minus 2 both sides.
Very good. And so these cancel. We have x minus 2 equals 3x. Our next step would be to,
Subtract x.
very good, negative 2 equals 2x. And our last step here would be to divide by 2. And we get x equals what?
-1.
Negative 1. Okay. And there's our answer. Are there any questions? And actually, I want you guys to go back here really quick before I finish. And whenever you get a negative answer, we said normally the negative answers will not work. If I were to plug a negative in here, we would have 3 times -1, which would make -3. Okay, and here you would have a -1 minus 2, which also makes a -3. Are you with me? But when we condense it, we get -3 over -3, which reduces and becomes a positive number. So we would be okay. But you always want to double check it, because if that wouldn't have worked out correctly, then that would be a no solution.
Does it happen often or
Not very often, but it can happen. So just be careful with negative answers. All right.